Okay, this question starts off with points A and B, but to begin with you don't know the full coordinates of B. But we do know the equation of the line AB, and we've got to find out the value of k, or show that k is 2, so this is where we need to end up. Well, our starting point for that has obviously got to be the point with coordinates 5k. The idea you need here is that if you know the coordinates of a point on the line and the equation, then when you take x to be 5 and y to be k, this equation works out to be true, so you substitute the coordinates into the equation, and that will give you enough information to end up with k equaling -2. Once you've got two pairs of coordinates, then the coordinates of a midpoint is a standard method from your notes. It's the second method in chapter 3, it'll be example 2. Then we've got to find the gradient of AB. Again, we now know the 2 points. Notice that if you didn't manage to show that k was -2, you still know what the coordinates of B are, so these methods should still be easy. The gradient of a straight line is example 3.1 from your chapter 3 booklet. Then in part C we've got another line that's perpendicular. AC is perpendicular to AB. We don't know anything about the point C yet, but that doesn't bother us, because all we've got to do first is find the gradient of AC. It's perpendicular to AB, and we've already got the gradient of AB, so you need to use your method for perpendicular gradients. That's the second stage of the gradient section in your chapter 3 booklet. You should be able to look up the property of perpendicular gradients and how to get one from the other. Then we need an equation of the line AC. Normal thing, you need for a line a point and a gradient to use in the y minus y1 recipe. Your point on the line AC, this time we don't know C, so the point is forced to be the point A, but we've got that, and we've got the gradient. So a point and a gradient are straightforward to set up, and then you can use the normal recipe for a straight line. And then, given the point C lies on the x-axis, we've got to find its x-coordinate. So this is telling us something about the point C. It's on the x-axis. Remember when we found intercepts, we said that at an x-intercept, the y-coordinate would be 0, and the x-coordinate, you can give this any letter you like. So we've got some coordinates here with a known y-coordinate. We've got to find the x-coordinate. This is like finding k was before. We substitute these two coordinates, that's a letter, that's a number, into the equation of a line we know C is on, which is the line AC, and we should be able to find that unknown coordinate.